Hello, everyone. So this is section 5.2. In this section, we will be learning a new technique of integration. So the technique here we'll be using is called substitution. All right. So this technique, can be applied for only certain problems. It is not applicable to all the problems. All right. So we will see on what kind of problems we can use this technique. All right. But before we start the technique, let me let's do something else first, and then we will start that. So let's say y is equals to x squared is given. Okay, and then we need to find dy. All right, so we need to find dy. So this is given, we need to find dy. All right, so, well, from here, well, if I take the derivative of y, which we can write y prime, or we can also write dy, right? dy over dx. The reason I have y here is, well, I'm integrating this function y. And the reason I have x here is this function is in terms of x. So I'm taking the derivative of this function, in terms of x. So that's why I have x here, right? So this is equals to, so if I take the derivative of this, it will be 2x, right? 2x to the power 2 minus 1, which would be just 1. So we can just say 2x. Now from this, if we are trying to find the value of dy, then just multiply dx in both sides. So we get dy, right? Right, so this value is dy. Or if you're looking for dx, then from this point, well, if you're looking for dx, then first we can, so what we can do here is, well, first we can just, again, like from this point, well, what we can do is, if you're looking for dx, then from this point, then we can just now divide both sides by 2x, so that will give the value of dx, which is 1 over 2x dy, right? So yeah, we can just divide and multiply things and get what we want, right? So we'll be using this idea later on. So let's start. Let me show you what does this thing, the integration by substitution, means from the example. So I will explain these things from the example. So let's show an example first. So let's say we want to find, or we want to integrate or find the integration of e to the power 3x dx. All right, so using this substitution technique, let's find the integration of this. Well, we know that the integration of e to the power x is, in terms of dx, is equals to e to the power x, right? Plus c, if there is x on the top. But we have 3x here on the top, right? So using this substitution technique, well, I can say that, okay, what I can do is, I can just assume this whole thing on the top by some variable. So let's just assume that variable is u is equals to 3x. All right. And then I can take, I can take the derivative of this u in terms of x. So I can say du over dx is equals to, so the integration of this in terms of x is, well, we just get 3, right? Okay. Now what we can do with this is, well, I can say e to the power, instead of saying now 3x, I can now assume u, right? Because we said u is equals to 3x. So let's just say u here. Now, since we have u here, so this, we are still taking the integration in terms of x, but since we are using substitution method, so I need to change this dx to du as well. All right. So we can get the value of the dx with this. So let's get the value of dx. So from here we can get, okay, so if you just multiply dx on both sides, we will get du is equals to 3 times dx. Well, since we're just looking the value of just dx, right? So from here we can just divide 3 on both sides, so that will give 1 over 3 du is equals to dx. So that means the dx value is this thing, 1 over 3 du. So here, this dx value, instead of saying that dx, now we have new equation, 1 over 3 times du. All right. So now here, this 1 over 3 is just a number, so I can just take that out. And we just have integration of e to the power u du, right? So if you take the integration of this, we will get 1 over 3, this is still e to the power u plus c. Okay, so now since the original equation is in terms of x, we got e to the power u. Now we can substitute this back to the x term. So 1 over 3 times e to the power, well, u is 3x plus c. All right. So yeah, so here, this whole process is called substitution method. So this technique here I used is substitution technique. All right. Because if you try to take the integration of e to the power 3x, it's not e to the power 3x. If there is e to the power x, then it is e to the power x, right? The integration of e to the power x is e to the power x, but integration of e to the power 3x is not e to the power 3x. It's this thing. All right, so we need to use this whole technique to get this answer. All right. Okay, similarly, let's do another one. Let's say x to the power 3 plus 2x plus 5 to the power 4 times 3x squared plus 2 dx, right? All right, so now here, again, we need to find the integration of this whole thing, right? So we have this big equation, right? It looks complex, right? If you just look at this equation, it looks, wow, it's hard, right? But one thing, well, here, since I'm asking you to use substitution, so there must be a way that we can use substitution, all right? So here, using substitution, well, we can see that if you, well, here we have this whole thing, right? So if you take the integration of this whole thing, you will get this, right? So x to the power 3 plus 2x plus 5, right? So if I take if I take the derivative of this whole thing, sorry, did I say integration? Yeah. If I take the derivative of this whole thing, I get this, right? So if I take the derivative of this, it will be 3x squared plus 2, right? So in these kind of case, again, we can use substitution method. All right, so again, we can assume this whole thing just u. All right, and then take the derivative of this. So that will give du over dx, right, is equals to 3x squared plus 2. Okay, now, well, assume this thing here inside the parenthesis u, right? This thing inside the parenthesis is u. This whole thing, if I, well, it looks like, well, if I just multiply both sides by dx, I will also get the value of, or some equation of this whole thing, new equation, right? So from here, from this point, well, if I just multiply both sides by dx, then I'll get du is equals to 3x squared plus 2 times dx, right? So that means I can substitute this whole thing by du, right? So I can substitute this whole thing by du, and this thing inside by u, right? So that means from this point, using this whole substitution, then I get new equation, which will be, well, yeah, this whole thing inside the parentheses u to the power 4. We still have that 4, right? And now this whole thing is du. All right, so there you go. This is now much simpler to integrate, right? So now using integration technique, now it will be u to the power 4 plus 1, right? Divide by 4 plus 1 plus c, right? So I showed this on the last video, right? 5.1. So from here we get u to the power 5 divided by 5 plus c. So again, we got the answer in u form, but the original equation is in x form. So now I can just substitute this back to x. So this u is this whole thing, right? So that means instead of u, I can write the whole thing again. So x to the power 3 plus 2x plus 5 divided by 5 plus c. All right, so this is the final answer. All right, so now let's do another one. E to the power t squared times t dt. Okay, so again here using substitution technique, now we can observe that, okay, here we have t squared, here we have t. So if I take the derivative of t squared, we will get 2t. So somehow we will get a t form, right? We'll get t if I take the derivative of t squared. So in this case, yeah, we can make it work. Okay, so just like I did here, let's now substitute this thing. Okay, you might think, why am I not just using this? Well, if now I'm saying that u is equals to t squared, right? But you might think, well, okay, why I'm not saying u is equals to this whole thing, e to the power t squared, right? You might say that. But in this case, we need to observe things, right? So from my observation, I can see that, okay, using t squared, or if I take the derivative of t squared, I get t. Somehow I get t. But if I take the derivative of this whole e to the power t squared, I won't get that. This will be even more complex, right? We'll get a complex equation, so that's not going to work. So the whole point of doing this substitution method is to make it simple, right? So now that's why I'm saying, okay, u is t squared. Now if I take the derivative of this in terms of x, no, sorry, in terms of t, because we have now t. So in terms of t is equals to 2t, right? Okay, now so I can substitute this whole thing by u. So again, I will get something new uh, for these whole thing, t times dt. So I can get that. So let's just multiply both side by dt. So it will be d. Let's see the same color. So du is equals to 2t dt, right? But here we just need t. We don't need this extra 2, so I can divide both sides by 2. So this will get 1/2 du is equals to t dt, right? So I just need some new equation of t dt in terms of u. So here I can replace this whole thing t dt by 1/2 du, right? So that means for this equation, we'll get a new equation using the substitution technique. So here we will get e to the power t square is u. That's what we said here, right? T squared is u. And this whole thing t dt is 1/2 du, right? And the reason I need u here is we have u here. So I need to take the integration in terms of u, right? Now, okay, now this is just a number. Again, I can take that out. So there you go. So now again, this is much simpler to integrate, right? So from here, I will get 1/2 e to the power u plus c, right? Always there must be plus c, some constant. Okay, now again, I can substitute this u back to this t. So 1/2 e to the power t square plus c. So this is the final answer. Okay, so here I'll be showing a few examples, all right? I'll be showing a few different examples. So when you do the homework problem, you will get some idea of, okay, what we need to do. Maybe, well, of course, you will get different problems, maybe not exactly same, but understanding the technique, you should be able to figure out things, all right? So the whole point of showing this few examples is to show you a few techniques for a few different problems. So understanding those techniques, you should be able to do those homework problems, all right? Of course, you can ask me, but yeah, so that's why I'm showing a few different examples. So this is the third one, second one, whatever, let's just say third one. Okay, so here, okay, what about this one? Take the integration of 1/3x plus 2 dx. Again, using substitution. Let's just take, well, if I take, well, let me just show you here. I think it would be better to explain. So let's just say u is this 3x plus 2. All right. So if I say u is 3x plus 2, then taking the derivative of this, I get just 3, right? A number. So if you just get a number, it will be a lot easier to work with. So now du is equals to multiplying dx on both sides, I will get 3 times dx. Okay, so now here I can replace this whole thing by u. So that way I'll get 1/u. So when you take the integration of 1 over a variable, right? I showed this in the last video. I get natural log of that variable, right? So that's why I just need just one variable. I don't need this whole thing, all right? So that's why we're using this substitution technique. Now, okay, now I just have dx. So to just get the value of dx, or just get the equation of dx, I can just now divide 3 on both sides. So I get the equation of dx, right? So I can replace this this dx by this whole thing, which is going to be in terms of u, and also this by, so this will be integration of 1 over 3x plus 2 is u, right? And this dx is 1 over 3 du, right? So again, I can take that out, 1 over 3 out. So I just have 1 over u du, right? So this is 1 over 3. So this is natural log of u. Well, natural log of u, like I said, this u must be greater than 0, right? So, or it should be a positive number to say that. You can also use the absolute value technique. So absolute value will always give a positive number from this, right? So yeah, so natural log of u plus c is equals to 1 over 3 natural log of, well, substituting, now if I substitute this back to x, then 3x plus 2 plus c, right? Okay, similarly, let me do one more. Let's say you have something like this. With the division. Okay. Now, yeah, so here, so this one is, so here, okay, so here what we can do is, all right, so we have x plus 2 here on the bottom, and on the top we just have x, right? So how can we make a relation between these two? If we take the derivative of this, we won't get anything in x, right? If we take the derivative of this, we'll just get 1. And here, well, yeah, we cannot make a connection, right? But what we can do here is, okay, let's do this, okay? Let's just say u is equals to this thing that is inside the root, okay? Let's just say that. So x plus 2, okay? Now from this, well, on the top we have x, right? So using this, I can also say that, well, x is, well, I can subtract both sides by -2. So x is u minus 2, right? From this equation, I can get that. Clear? Okay. Now, so here I can replace this by this whole thing, u minus 2. And also I can replace this whole thing, x plus 2 by u. Basically, I'm trying to change this to a u form, right? But what about dx? What can we do with dx? Well, yeah, I can take the integration of this dx over du, right? Now x is going to be, this dx is going to be on the top and du is going to be on the bottom, because we have x is equals to this whole thing. So from here, I'm taking the derivative of this x equation, so dx over du, because we are taking the derivative of this whole thing. We're taking the derivative of this whole thing that is in u, so that's why you have u on the bottom. So, okay, now here, taking the derivative of u will be just 1, right? So now just multiply both sides by du, so you will get dx is equals to du. All right, so now from here again, on the top we said x is u minus 2. On the bottom we get square root of x plus 2 is u. And we said dx is du, right? Yeah, it's a little bit confusing, but yes, it's just that I'm just doing few algebra, well, and just replacing things or substituting things. Uh, that's all I've done so far. All right. Now, after this, okay, after this, we can now split this into two parts, right? Or we can just say u over square root of u minus 2 over square root of u and du, right? So from here, again, I can say the integration of, well, integration of u, or basically u over square root of u is also same as u over u to the power 1 over 2, right? And this is also, since this has the same base, so, and these are dividing, so I can even say u to the power 1 minus 1 over 2, right? Because this one has the power of 1. Okay, so this is also same as u to the power 1 over 2. So from here, I get u to the power 1 over 2 minus, well, square root of u is also u to the power 1/2. I can move that to the top, so this will be 2 times u to the power negative 1/2, right? And du. Okay, now we can take the integration, right? So we can take this into integration separately. Now I can just take the integration of this and then integration of this. All right, so if I take the integration of this, we will get u to the power 1/2 plus 1 over 1/2 plus 1 minus 2 times u to the power minus 1/2 plus 1 over minus 1/2 plus 1. All right, so after you take the integration, please do not forget to write the constant. All right, now after this, okay, on the top, 1/2 plus 1 is 3 over 2 over 3 over 2 minus u to the power negative 1/2 plus 1 is positive 1/2. And this is also positive 1/2 plus c. Now, I can move this, well, I can move this to the top, so the 2 will go to the top. U to the power 3 over 2 over 3 minus, again, this will go to the top, and 2 times 2 will give 4, u to the power 1/2 plus c. Right, now you can substitute this u back to x, so I will get 2 over 3. So u is x plus 2 to the power 3 over 2 minus 4 times, again, u is x plus 2 to the power 1/2 plus c. There you go. All right. Okay, so let's do one more. Let's say, now, what if we have something like this? 5 times x squared plus or over x to the power 3 plus 4 square dx. Okay, so here we have x to the power 3, here x squared. So if I take the derivative of x to the power 3, I will get x squared, right? I'll get x squared. So that's why let's just say this thing on the bottom, or this thing inside the parenthesis, u. Right, now if I take the derivative of this, I'll get du is equals to 3x squared, right? Or du over dx, right? Now after this, since I have dx here, and also I have 5x squared, but 5, I can just move that 5. So for this one, I can basically just say, I can bring that 5 out. So I'll just have square the integration of x squared dx over x to the power 3 plus 4 squared, right? I can even write like this. Now here, okay, so I can replace this by u. I can replace, okay, so here I can do, here I can just multiply dx on both sides. So du is equals to 3x squared dx. Since I'm just looking for x squared dx, the equation of x squared dx, where I still have this 3 extra, so divide 3 on both sides. So 1 over 3 du equals to x squared dx. All right, so that means now here I will get a new equation. Well, still have that 5. The integration x squared dx can be replaced by 1 over 3 du, right? That is on the top. Over here, this thing is u, right? X cubed plus 4 is u, and still have this square, right? Now again, this is just 1 over 3, just the number. I can take that out, so it will be just 5 over 3. So 1 over, or u square, I can move, again, I can move that u square to the top, so it will be u to the power -2 du, right? Okay, now this one, I can, this is much simpler to integrate, right? So then in taking the integration, I get u to the power -2 plus 1 over -2 plus 1 plus c, right? And then this will give u to the power -1, and -2 plus 1 is also -1 plus c. So I can bring this negative here, so it will be -5 over 3. And again, I can move this back to the denominator. So this will be positive, or u to the power +1, right? Clear? So I'm bringing this negative here. This is this negative, and I'm moving this u to the denominator. So if I move this u to the denominator, this power will be positive, right? Plus c. Okay, now substitute this back to x. So this will give -5 over 3, 1 over x to the power 3 plus 4 plus c. All right. So yeah, I showed a few different examples. So I guess this will help you to do the Pearson homework problems. All right. And of course, if you have any questions, you can always ask me during my office hour. And I think maybe some of you guys do not know about my office hour, right? Because I've sent this email a few times. And I just want to remind you again, my office hour is Monday and Wednesday. All right, Monday and Wednesday from 10 a.m. to 11 a.m. But if you want to talk to me any other time, just send me an email so we can set up a time that will work for both, for you and me. And then I can help you through Zoom. Okay, so you can find the Zoom link in the Blackboard, and you will see the office hour link or Zoom office hour link, something like that. Zoom office hour. So you'll find the link there. You will find the password and everything. So you just have to make a few click and you can get into the Zoom. All right. So please come to this Zoom if you have any questions. All right. Okay. I'll see you in the next video. Thank you.